even, odd, or neither. So to determine this, we want to take a look at the symmetry. So one of the first things that we notice is that this graph does go through the origin. And if we look at some points that are opposite in x value, notice that they are also opposite in y value. So we're seeing symmetry about the origin here. So as you move the same distance left and right from the origin, those output values are going to be opposites. So this is an example of an odd function. In our second example here, we're given a table to work with. And so we're given 5 different x inputs, and then we're finding the y values that go with them. So compare some opposite values as we're working here. So for opposite x values, -2 and +2, we see opposite y values, 3 and -3. But when we look at opposite inputs, -1 and +1, we see the same output of +1 in both cases. So for one, we have opposite inputs giving opposite outputs, but for another pair, we have its opposite inputs giving us the same output. So this is neither even nor odd. So it doesn't follow the rule for all of the pairs for either one. So what if instead of a graph or a table, we're actually given the formula or the equation for our function to work with? Let's take a look at this example here. So we're given the function f of x equals x to the 4th minus x squared plus 1. So what we're going to do is we're actually going to evaluate this function. We're going to evaluate it for the input -x. So rather than looking just at one specific number, we're saying what happens if we look at the opposite input for any x value. So plugging in, we'd have -x to the 4th minus -x squared plus 1. So now we want to come through and actually simplify this so that we can compare it to the original function. So if you multiply -x times -x times -x times -x, those negatives are going to pair up and cancel out, and this is going to leave a positive x to the 4th. The same with -x times -x. When we're squaring, the negatives are going to cancel out, so we're left with just minus x squared plus 1. So what we want to do is take the original function and compare this to the new function that we have created. So the thing that we notice when we compare these is that these are exactly the same function. So because we have found that f of -x is equal to f of x, so for opposite inputs, you'll always get the same output. This is telling us that we have an even function. So we could graph this function to confirm that. Just to make sure that's clear, let's look at one last example. What if our function had been x to the 3rd minus x plus 1, and we wanted to know is this even, odd, or neither? So same plan, we're going to evaluate at f of -x as our input. So I have a -x cubed minus a -x plus 1. So here, negative times negative times negative, 2 of those negatives will cancel out, but we're still left with a negative. So it's still going to be the opposite of x to the 3rd. Negative times negative, we're going to have plus x plus 1. So just as we did before, take the original function and take what we got when we evaluated f of -x and compare these two. They are not the same for sure. So if they're not the same, then we know that this is not an even function. So we look to see if they are opposites. If they were opposites, every single one of the signs needs to change. So in the first term, it went from positive to negative. That sign changed. The second term went from negative to positive. That sign changed. But the third term was +1, and now it's still +1. So this means they are not opposites because not all of the signs changed. So we would need every single sign to change for them to be opposites. So they're not the same, it's not even. They're not opposites, it's not odd, so this one is neither even nor odd. It does not have any of the special symmetry either about the y-axis or about the origin. So given a graph, we can look at key points to see if we have any symmetry. For a table, compare values that have opposite inputs to see what's happening with the outputs. If you're given a formula for the function, evaluate at f of negative x and compare that simplified expression to the original function to see if they are same or opposites to tell us that we have either even or odd functions.